Okay, so maybe it is difficult in the beginning, but you just read it. It is understandable. It is not a difficult thing. It is just a process. Okay, you need to understand how this mechanism works. Okay, so next we'll move on to, there is one more small topic, that is USB. How USB works. I think everybody knows about USB to connect your pen drive. Okay, all the peripheral devices, keyboard, mouse. We need USB. Okay, so we'll just go with this USB. How USB is connected to the processor bus. Okay, so you can just quickly go to the previous diagram, main block diagram. You can see how USB is connected. Okay, keyboard. So if you have any gaming device, okay, video, so all these type of devices will be connected through USB, and USB is handled by the special controller called USB controller. So similar to SCSI controller. So it is an interface where it is going to control these devices. So how these USB is going to help in connecting the devices. There are so many companies that have developed different types of USB with respect to the speed. So we'll just go through that example. So there is Compaq or HP, Intel, Microsoft. So all are these companies, or they have developed different types of USB. Okay, and it is going to vary based on the speed operation. So how fast it can send the data. Okay, so it is mainly classified into three categories. The speed, it can be classified into three categories. One is low speed, full speed, and high speed. Okay, so low speed indicates it can send the data. Okay, whatever the USB port you can have, no, so that can send the data up to 1.5 megabits per second. If it is full speed, it is 12 megabits per second. If it is high speed, you just observe, so that is 480 megabits per second it can send the data. Okay, so this is just a classification about the speed of the USB. Different operations that can be done using low speed, full speed, and high speed, and this is a data rate. So what are the objectives? Why we need this USB? Okay, why we need this USB? Why they have designed this? It is very simple. Simple in the sense, easily you can just attach the devices, easily you can plug, and if you are not using, you can unplug it. So it is nothing but plug and play devices. Okay, you can just use it as a plug and play devices, and it is low cost. Okay, compared to the other two buses, the USB bus is low cost, easy to use interconnection system that covers the difficulty due to a limited number of IO ports available in the computer. Okay, so normally now you can attach so many devices. Okay, so you can just buy a external device where you can have more number of ports. Okay, you can connect more number of IO devices, all different peripheral devices with the help of that device. Okay, so normally for the laptop or a desktop you will be having limited USB ports. If you want to connect more number of ports, you have to buy one external device where you can have more number of ports. So that is supported by the USB. Okay, but normally in the system it is very limited number of IO ports. It will be there either in laptop or desktop system. Okay, and also it supports for wide range of data transfer characteristics for IO devices. So wide range in the sense with respect to the rate or the speed. So that we have already discussed three variation of speed. So at what speed the data can be transmitted using USB. Okay, it enhances the user convenience. It is so convenient that using USB you can easily attach the new device. Just it is a plug, and you can start using that particular device. Okay, for storing the data or transmission of data, anything you can just use it uh, by using plug and play. So yes, USB helps add many devices to the computer system at any time without opening the computer box. Okay, you just imagine if there is no ports. Okay, if you don't have any ports, so how difficult it is to connect the new devices. Exam Example, if you take old systems, it's too difficult to attach the new devices to that particular old system. But nowadays you're getting so many additional the extra devices where you can have many number of USB to connect the devices. Okay, this is just a brief introduction about USB, that is Universal Serial Bus. So why it is the term given serial means it is going to transmit the data bit by bit. So now in this USB, mainly we are going to discuss, one is architecture and another one is addressing and one more is protocol. Okay, so three concepts you are going to learn. I'll just explain in brief about this architecture, addressing and protocol. Quickly we can just go through that. So you can just observe this diagram. Okay, maybe you may not understand, like if you are connecting IO devices, so is it the whatever the device you are connecting, it look like this? Okay, you will be just able to see the ports, USB ports, but internally you just observe it is not directly connected to the computer system. Okay, so you can see there is in between we have a hub. With the help of hub you can connect the IO devices. So this is the main host computer. Okay, so this is the main host computer. It can accommodate large number of devices that can be added or removed at any time. Okay, there is no restriction, you can add as long as how many ports it supports your device, you can just keep on add the devices. Okay, if you are not using, you can just remove that particular device, IO device from the port, and you can disconnect it. So each node in the tree has a device called hub. Okay, that you may not able to view as a user, but that is there in internal system. Okay, so each node in the tree has a device. This is called device. Okay, it is called as hub, and the devices are not directly connected to the root hub. It is connected with the help of hub. Okay, it is just an intermediate control point for controlling the IO devices between the host and IO devices. You can just see this is the connection of USB devices. It is done or it is represented using tree structure. Maybe you know what do you mean by tree here. Okay, so where these are all nodes. Okay, and each node it is connected with another sub node, and this sub node it is having child node or leaf node we can call. So this whatever the leaves you can see here, so these are all IO devices. Okay, so the leaves nodes we call it as IO devices, and these IO devices are connected through hub. That is the intermediate control point between the host. This is the host computer, that is the main system, and whatever the device you are attaching, example your pen drive. Okay, so that is an external device that is not directly connected, that is connected with the help of hub. So normally you can use this example for the devices that are connected using USB, that is keyboard, internet connection, speaker. Okay, even you can connect to digital TV. So these are all an example of the USB bus. So now how exactly the operation takes place with respect to this tree structure. Okay, the operation means how the message is sent. So here the hub copies the message that receives from the upper stream connection. Upper stream means the host. Okay, lower stream means or downstream means the actual IO devices. In between there is a hub. Okay, so a hub copies the message that receives from its upstream connection to all its downstream ports. Okay, depending on which device you are using. If you are using a keyboard, okay, if you are using a monitor, okay, display, so whenever if the host want to display something on the output device, it is going to send the message from host computer to hub, then hub to IO device. Okay, so are you able to understand? It's very simple how data is moving between the host computer and IO device. I'm just explaining. Okay, to which device? Okay, to which device, that also should be addressed by the host computer. To which device it want to send the data, it should be addressed by the host computer. Okay, so now what is happening whenever the message is sent? I think you have not yet learned networks, no? In LAN, what happens? Local area network, if you have studied, okay, whichever the device it is connected to the LAN. So for all the device, it is going to send the data, okay, and it will check the address to whomever it is addressed. Only that device it will accept that information. Same thing happens here, okay. So the message sent by the host computer is broadcasted. Broadcasted means it is sent to all the hub, then followed by to all the device it is going to send. What is the necessity of doing that? In that way, if you do, what happens? Which device is going to respond? So to whichever the device it is addressed, only that device, consider if this is a device the host computer has specified, then only this device it will accept that information. So all other IO devices it will discard the information, indicating that it is not addressed for that device. So that is how data flow from host computer to the IO device. So now in case if the data should be sent from IO device to the host computer, how it is going to take place? Okay, consider if this is the keyboard, I want to send the data or from the input device, okay, how it is sent to the host computer. So a message from an IO device is sent only upstream towards the root of the tree, okay, and that is not seen by any other device, okay. If it is very specific to host computer, it will just go to hub, then next hub, then followed by the main host computer, okay. Only when it is sent by the host computer it is going to broadcast, so that it will be sent to all device, and it is responded only by one device that is matching with the address, okay. So that is how the USB structure or the architecture is implemented, okay. Very simple. Just draw this diagram and you should able to explain how it works. Next we'll move on to addressing, okay. What type of addressing it is going to use? USB, because so many times we are going to connect the we'll connect our system with new devices, we'll remove the devices. So how the system is going to identify the new devices are attached, okay. So what type of addressing mechanism it uses? So when USB is connected to a host computer, okay, so its root hub is attached to the processor bus where it appears as a single device, okay. For me, when I connect to the keyboard, okay, I feel that it is just a single device, I am just connecting directly to the computer system, but internally there is something different it is happening. It is not directly connected to the host computer. The host software communicate with the individual devices attached to the USB by sending the packet information, okay. So what is this packet information? How to represent the packet information, that we have in the next topic. So packet means it is nothing but data. Just remember, it is nothing but data. Okay. So now whatever the information that is to be sent to the host, that will be sent by a particular IO device. So which route the hub forward to appear the device in the USB tree. Okay. Then each device on the USB, whether it is a hub or IO device, it is assigned 7-bit address. Okay, now I am just talking about the identifying the device attached to the computer. Okay, it will be having a 7-bit address. 7-bit address. So what are these 7-bit indicates, that we'll discuss. So this address is local to the USB tree. Say that is also very important. So whatever the address we are doing using with respect to IO device here, it is very local to this hub, okay, and this is not the main device ID, okay, it is local to the hub. Okay, so this address is local to the USB tree and it is not related anyway to the address used by the processor bus. Do you remember I told so many times? So the processor is going to specify the address of the device to send that information. Okay, many times I used. So that is not the address we are discussing. So we are discussing the address with respect to the IO device that is local to the hub or tree structure, USB tree structure. Only for this part of the structure, we are discussing the ID allocated to each IO device is of size 7-bit. So now hub may have any number of devices or other hub it connected to it. So that you can just see here in the diagram. So hub can have any number of devices connected, or you can see here there are 3 devices connected here. In this you have another hub is connected. With the help of this hub, once again 2 more devices are connected. Okay, it can have any number of hubs and also IO device. What is hub? Don't get confused. It is just an intermediate node to connect IO device and host computer. Okay, so now I told so many times we are going to attach new device and we are going to remove. How system will come to know that? Okay, how it is going to come to know that? So I told using 7-bit address. So here, other than that, it is something is going to happen here. So when a device first connected to a hub, okay, or when it is powered on, it has the address 0. Okay, initially whenever new device you connect, so it will be having address 0. The hardware of the hub to which this device is connected is capable of detecting the device that has been connected. So now hub is going to take care of, okay, so this hub is going to come to know that there is new device attached. Okay, whenever if you are trying to connect new device, so initially the address is going to be 0. And it records this fact that part of its own status information. Okay, so hub is going to just, it will note down the information that whatever the new device that is attached. Periodically host polls each hub to collect the information and learn new devices that have been added or disconnected. Okay, so now I am just talking about here hub. Now how host computer will come to know that new devices are attached. Now I am trying to connect my mouse. Okay, how host computer is going to come to know that? Because I am maintaining the information only at the hub level. For that, the host computer is going to poll. Okay, so periodically, okay, it will keep some standard time, maybe every 3 seconds or every 5 minutes. It is going to periodically check the state of the hub. Is it any new device? Hub is going to maintain some table. Okay, in case if new devices are added, okay, it will keep track of those new device details. Okay, when host computer checks this hub by polling, if any new devices are added or there may be possibility it is disconnected, so that information the host computer is going to collect. So that is how the addressing it is going to learn. Like addressing means, so which are the devices that are connected, new devices, or which are the devices that are removed from the system. Okay, so that will learn with the help of hub. So next we'll move on to protocol. Okay, so whenever if some particular operation to takes place, it has to follow the standard rules. Okay, standard set of rules defined by that particular method. So your protocol is nothing but there's a set of rules to be followed. Standard format should be followed to perform the operation. Okay, hardly I may take 5 more or 6 more minutes to complete this. Just be there so that I'll finish module 2. So now when I think this is also important, many times I asked USB protocol, explain USB protocol. It's very simple. You need to draw these diagrams, okay, what and all information it is there and how the data transmission takes place. So all information transferred over the USB is organized in packet. Okay, so instead of I use the term data many times. So here they are going to represent data in the form of packet. So packet indicates it may consist of one or more byte of information. So there are many type of packet that perform variety of control functions. It is not only data, the packet can also have the control information. Okay, control information is nothing but we have discussed no handshake protocol, master ready, slave ready signals. So those are all control information. So that also represented using packet. Okay, so that is one is control and data packet. So control packet performs tasks such as addressing the device to initiate the transfer. See, control information means it is going to initiate the transfer. Okay, it will tell I am ready. Okay, then this particular device, it starts sending the data. In case if this device successfully received the information, it has to respond back to the initiator by sending an acknowledgement. So this initiation or request and acknowledgement, this we call it as a control packet. Okay, control packet, initiator of the data transfer, acknowledging the data being received. So these are all called control packet. Data packet means that is the actual information. Okay, that is the actual information it want to deliver. The packet consists of one or more fields containing different kind of information. Okay, when I tell packet, it can be a control packet or it can be a data packet. And in a packet, once again, if you go in depth, what packet contains. So the first field of any packet is called packet identifier. Okay, that means address. When you take a letter, what is the first thing you can see on the letter? If somebody has sent a letter, you will see the address. Similarly, here it requires the ID, packet ID. That is the identifier. Okay, PID, which identifies the type of that packet. Okay, so that indicates is it a data packet or control packet. So whenever if PID is there, it indicates what type of packet it is. So how many bits allocated for this PID? It is 8 bits. Okay, they are transmitted twice. So this PID information, it is stored twice. Okay, so the first set of bits indicates the value PID, and the remaining bits, it is just negation of that information. Okay, so the first time they have sent their true value, second time it is going to be complement. It is just one standard protocol. Okay, they are designed. First it will send the PID details, 4 bits. Okay, PID 0 to 3. After that, remaining 4 PID indicates it is a complement value of the first 4 bit. Okay, just remember, it is a PID indicates packet identifier, indicating is it a control packet or data packet. Next, we have a token packet or data packet. So you can just observe. So one is PID, I told it is 8 bits. So first 4 bits the actual ID, and remaining 4 bits indicates the negation of the first 4 bits. Okay, PID, that is packet ID. Next, address. ADR stands for address. Then end address. Okay, end address in the sense, just a minute. Okay, this is the end of the packet. It indicates the end of the packet, and there is one more field called CRC16. See, whenever the data is transmitting in the network, okay, so you are sitting somewhere else, okay, somebody else is in the other place. When you are communicating, so the data has to go through the network. So whenever if it is transmitting through the network due to noise, okay, due to some other network issues, there may be chances of the data may get corrupted. If you are trying to send 1001, okay, during transmission, maybe this particular bit 1 is changed to 0. What happens here at the receiver side? So the data is received incorrectly. Okay, so now it should not happen like that. Okay, many times we are receiving the information either through mail or phone. Every time we'll, most of the time we'll get the correct information. Then how it is going to take care? That you are going to learn in computer networks. Okay, data communication or computer network, where it uses the error correction mechanism. So that is called CRC16. This is the technique used for correcting, identifying the error and correcting the error. Okay, I will not go in detail. Just remember CSC16 indicates error detection and correction. If anything, it will come to know that for that. Okay, so one more step I need to go to tell the CSC. How it will come to know that the receiver, there is an error in the received data. For that, the sender has to send extra bits. Maybe if you have remembered, I told ECC, error checking code, how data is stored in the disk. Okay, whenever if it is retrieving, it has to check ECC, error checking code. Is it it is having any error in the stored data? Okay, there are different techniques. So this is with respect to disk, and this is with respect to network. Okay, whenever data transmitted through the network, there may be possibility of corruption. For that, reason, so here the sender is going to use some technique to generate some additional bits. Okay, so it will use some additional method to identify what are the extra bits should be added. Okay, that is added along with the data and it is sent to the receiver. Now receiver can make use of these extra bits to identify is if there is any error or not. Okay, just remember that. I don't want to go in detail. It is one complete class it will take to explain how CRC works. Just remember it is error detection and correction code. Okay, so this is control packet. This is control packet used for controlling the data transfer operation, and here we have the actual data packet. Okay, actual data packet indicates the packet ID followed by what data to transfer, how many bytes of data. Then maximum it is 0 to 8192 byte of data can be transferred at a time. That is the maximum size of the data packet. Then followed by some fields it is indicating for CRC 16 bits. Okay, that is used for error checking and correction. So this is all about the USB protocol. So anybody is having doubt how USB protocol works? I think I have one diagram here. Just 1 minute. So here host, that is a host computer. You just recall the tree structure. The same thing I am just drawing with the help of straight line indicating how operation is going to take place. This diagram I have written. So host computer and there is a hub and there is a IO device. Now how communication takes place. Okay. So you need to draw this diagram if they ask for USB protocol, that packet formats followed by how data transmission takes place. Host computer. Okay. So it is first it is going to send the control packet. Okay, control packet indicating that is it the device is available or device is ready, to know that it is going to send the token. Okay, and also after that it is going to, if the device is ready, okay, so the host is going to start the sending the data. Okay, data 0, that means first sequence of data is sent to hub. Okay, if hub is received the data successfully, it will send an acknowledgement. Okay, so why this slant line indicates, it indicates the time information. As soon as the data is sent, it is not received at the same time, there is a delay. For that reason, so there is a slant line written. Okay, acknowledgement is sent indicating whatever the data it is sent, it is received successfully. Okay, token is sent. Next, this hub, whatever the data it is received, that is going to deliver to the respective IO device. See, your token indicates the address and packet ID, the device address. Okay, address which IO device it is representing. So that to that particular IO device, it is going to send the token first. On receiving this token, whichever the device that match with the address, it will respond. Okay, so then followed by it is going to send the data. Then whichever the device that receives the data successfully, okay, it is going to send an acknowledgement. I already told moving of data from host to computer, where it will send the data to all the device. Okay, that will be accepted by only one particular device, that is addressed. Okay, broadcasting. If it is data moving from downstream to upstream, so the data will be sent to from IO device to hub, then directly to the host computer, not to any other IO device.